right. So we good? So the second part of this kind of initial best practices here is around searching for data and synchronizing data in a mailbox folder. So these are kind of obviously common client scenarios. Again, this isn't what I'm talking about here are general best practices. If you're going to write your own client, this isn't necessarily exactly how Outlook 2011 does anything. But it's the same operations that it's going to use. So if you're looking to understand product behavior, these are the operations that it's going to use to synchronize data and search. So initially, we'll just talk about searching. We'll talk about notifications. Then we'll talk about synchronization. And then we'll kind of put notification plus synchronization together in a pattern that you would use in your own application. This pattern would also be something that you'd see a client do. If you're looking to monitor every mailbox in an organization as a service, this pattern is still very relevant. So first, searching. So again, this is all done via the find item. So when we're searching for items in a mailbox, we can do this in various different ways with a find item request. And we'll walk through the protocol around that, what those requests look like. So these first three are actually kind of concrete ways that the protocol enables searching. The fourth bullet here is more about kind of an implementation detail around a best practices of how you would use find item to do client-side searching. So you're gonna gather the data from Exchange in an efficient manner, pull it down, and then search on the client. And we'll talk about why that's important. And then obviously with EWS, we can create search folders. You're probably familiar with them if you've used Outlook. So you can create a persistent search folder with EWS. And those are useful. You can do them programmatically, not just from a client benefit so that a user could use it, but also if your app needs, only cares about items, any item in the mailbox with a particular message class, you can use a search folder, do something like that. There's another type of search that we have in Exchange 2010 and later in Exchange Online, which is like a multi-mailbox search. So you're doing a discovery search across every mailbox in an organization. We're not going to talk about that here. That's done via PowerShell. It's discussed on TechNet. It's called a discovery search. And you can initiate that. And then the results are actually brought back into what's called a discovery mailbox. And then you can access that mailbox with EWS. So read more if you're interested in that in this TechNet link. Look for information on discovery search. We also have an MSDN article that just kind of covers a lot of these topics in more depth and gives you some examples, some sample SOAP, and I think managed API code for searching mailboxes. So they go through all these different scenarios. So first one to talk about, this is another example of one of the scenarios where I'm going to show you something and I'm going to tell you not to do it. This is a find item plus a restriction. And so we've talked about the basic pieces of a find item. They're all the same: index page view, the property set that you're requesting. We're following best practices. We're doing the ID only and explicit property set. Here's where it's documented in our protocol. So there's an additional element that you can add to the bottom here, this restriction element. And basically, what you're doing here is you're setting, if you're familiar with MAPI, it's the same kind of restriction. You're setting a search criteria on this against any property. What that does in the background is it creates a hidden search folder. We'll talk about that in a little bit and why that's a bad idea. But in this case, what I'm doing is I'm searching for every up to 100 items in my inbox. I'm going to pull the subject, sender, and from, and I'm looking for any items that have EWS in the subject. So that's what that request does. Find item and query string. So this is another additional element. This is new to Exchange 2010. And this query string element documented here in the protocol. And here's the MSDN link. And you'll see it's doing the exact same thing. It's far simpler. Just this query string element at the bottom. And then we hand it this. This is a special syntax here, which is documented in the MSDN reference. So we're looking for the subject that contains EWS. And so in this case, what we're using is called an AQS string, and I forget what AQS stands for actually. But it's documented here. So what it is essentially is a set of indexed fields on a given item that you can search on. So this is nice, it's very efficient, but there's a limited set of fields that you can search on. So like a restriction where you could search on any property and any value of any property. Here you're somewhat limited, but this is much preferred to a restriction. We'll talk about that in a little bit. And then finally, we have this idea of a calendar view element. And this is obviously for calendar scenarios with appointments. So we're searching for a date range. So we give it a start date and end date in a calendar and display that. So an interesting thing about this, if you're looking at, if you haven't done a lot of Exchange development before, it's important to note that in the calendar folder, when we talk about things like recurring appointments, so you actually in the calendar folder have one item that represents a recurring series of appointments. So when you look at it visually in Outlook, you maybe have an appointment that recurs every day of the week. So it recurs Monday through Friday every day. There's actually one physical item in the calendar folder that has a recurrence pattern that states that item repeats every day for the week. So if you were to search just based on the items, so if you're doing a find item and you were just pulling back the individual items in that folder, you'd only get one item. If you use this calendar view and you search within a date range, you actually get occurrences back, so you get individual occurrence items back for each occurrence of that recurring appointment. So if you're thinking about implementing a client and you're looking at the view you get in Outlook of, say, like a work week, you would use a calendar view in this scenario to make sure you expand all of those recurring appointments out, those series out, so that you can properly display them in a given calendar view for a different given date range. So any kind of searching you do in a calendar, you should probably do it with a calendar view to limit your scope of searches and properly expand the recurrence patterns. Okay, so now to best practices and not doing what I just told you about. So do not pass a restriction with find items. So again, I talked about this a little bit. That restriction element creates a hidden search folder in the mailbox. The way a search folder works is that it basically has a query associated with it, that one that you set up. It lives for a period of time as long as it's being utilized. It'll eventually time out or age out and be cleaned up. But for a number of days, it will live in that mailbox. And as you edit items within the folders that search folder is looking at, it is going to update its result set. So there's a performance impact of creating a search folder that you don't really need and aren't going to really use again. You just create it one time. And then you go through and you're editing, updating items. And that could be through an Outlook client or an OA client, EAS client, whatever. There's an impact from that point forward for all the activity that goes on in the mailbox. So it's not a good idea to use a restriction, especially in a situation where you're doing a unique search every time. So you're doing like a find item, and you're using that restriction to take input from the user to search for this, this name or that name in the subject or whatever. You wouldn't want to use a restriction for that. What you would want to use instead, if possible, is query strings. And so that's that second example I showed you where the query element, and you're searching only for indexed fields, but there's quite a few of them for kind of your basic fields of different date, time, sent, subject, body, that kind of thing. Recipients, sender, that kind of thing can be queried there. So if that's what you're interested in, using that query string is definitely a better option. Then the final option, if you need to do kind of a more formalized or expansive searching, you don't want to use a restriction, but query string doesn't do enough for you. Then you use find items, get all of the contents locally, use a paged view, maybe with a sort order. So if you're looking for like every item within a specific date range, you might do a sort, the paged view, and then you can start retrieving the items. And then once you've found every item within your range, then you just you don't make subsequent find item calls. You may sort alphabetically by subject to try to look for a subject that starts with a particular letter, that kind of thing. You would only ask for the properties that you need to execute your search. So what you're doing is using the find item to pull all of your contents down for all the fields that you want to search through, the minimal amount of fields, and you also get the item ID and the change key for all those items. So then once you pare that down to the ones you care about, then you make a get item request to follow up and get the details for those items. So that's a much better way to do searching, even though it requires more work for your client, than using a restriction. So important to note, this is one of those scenarios where you actually might not find a client. If you're looking to understand client behavior, I would test with that client and see what it's doing. It might be using a restriction versus this find items. If you're writing a service, though, and you're especially doing kind of searches at scale, you definitely want to consider doing those searches on the client in this last section here. So another option would be using search folders. This is kind of, so the idea of when you're using a restriction, you create a hidden search folder that you can't go back and delete. But you can create, just intentionally, a search folder. You can make that visible to the user if you're trying to create a search folder like you'd use in Outlook. But you can create a search folder that maybe for your service might be of value. So all the items in a mailbox of your item type, or all the items sent from your service account, or something like that. That gives you a folder. It looks exactly like a folder to you with items in it that meet that criteria. And so you can create that. There are some costs with it, but if you're using the same search every time, you know you always need that, it becomes an optimization for you. So you already have those items pre-populated. So the initial population may be somewhat of a cost, but then if you're going back to that search folder over time, or you can actually subscribe to notifications for that particular search folder, then you're not monitoring or trying to navigate through all the folders in a mailbox. You're just going right back to the search folder each time. And so over time, you end up optimizing your overall throughput. So again, this is kind of that note that happens for any search folder. Every event in a mailbox results in an evaluation, potential write of all search folders in that mailbox. So as events happen, as things change, these search folder results get evaluated over and over again. So you want to be careful not to overdo it, but understand that there are places where it makes sense. If after a period of time you're done with them, clean them up. So this is what you can't do with a find item plus restriction, which you can do if you explicitly are creating a search folder. You get a pointer to that has a folder ID, and then you can go back and call a delete folder, pass it that ID, and clean up your search folder. You wouldn't want to do this for a one-time search, though. Use a query string instead, or client-side searching. So this would be, you'd be cleaning this up if you were like uninstalling, or you were updating. You had an old search restriction on a search folder, and you're updating it, so you're creating a new search folder. Delete your old one, that kind of thing. Any questions on searching? Yes?
Just two questions. So with regard to using restrictions for the generation of these search folders, do you have a scenario where a user is using both OA for specific times and Outlook at other times? Does OA generate the hidden search folders? Is there a case where that would happen and then the user actually ends up seeing it in Outlook?
So the question is, if a user creates like a search folder in OA, is that visible in Outlook? And if we're creating them in EWS, are they visible in Outlook? Yeah. I'm not exactly sure how that works with OA. With EWS, there's properties you set on a search folder to make them visible to the user or not. So you could create a search folder for your service that you don't want to be visible, and you could hide it from the user, or you can make it visible if you wanted it to. Any other questions? So notifications. So this next section is about a basic client scenario. We're trying to be notified of events because we're trying to keep a client in sync with what's actually in the mailbox. So the first step of that is notifications. Notifications involve kind of two-step process. So we subscribe to a folder or a set of folders, and then we get events from that subscription. So notifications are asynchronous folder and item event notification mechanisms. They're not synchronous. We had the idea of synchronous store event syncs all the way up to Exchange 2007. That's gone now, so that was actually like a DLL that you installed on the Exchange server. And that would actually have the ability to give you a synchronous event. So you're actually injecting code into the save or delete event and being able to cancel a save or delete on the Exchange server. That's not what notifications do. There's nothing in EWS that does that, primarily because this is a SOAP-based web service, and so it doesn't really make sense to hold up a database commit on an asynchronous web service call. The client subscribes to receive notifications. There's 3 different mechanisms for receiving those notifications. And then an important note here on the bottom, which we can show in a demo, is these subscriptions that you create are maintained on the client access server role. So if you're not familiar with Exchange architecture, you have the client access role, which can be broken out on a separate machine and arranged in an array of servers that are backended by a mailbox server role. So when we're talking about notifications and subscriptions, the subscriptions are stored at the client access server role. So that's important, important to note when we talk about throttling and affinity tomorrow. Your subscription that you maintain is with one CAS server. So if you have an array of CAS servers, it's important to get your requests for events back to that same CAS server, which knows about your subscription. It also creates an implication for resiliency. So if you have CAS servers in an array, and you have your subscription is stored on CAS server 1, and that CAS server goes down, you've lost your subscription. So you're going to get an error back the next time you try to get events, or you're just not going to hear from that CAS server, depending on the event model that you're using, and so you're going to have to resubscribe. So it's important to remember that. A lot of people use notifications to as a synchronization method, and not wanting to miss events, things like that, not wanting to miss changes that happen. But it's important to remember that you can definitely miss events if you're just relying on notifications. So we'll talk about how to mitigate that with synchronization next. Again, if you're familiar with store event syncs, it's similar, but it's asynchronous. There's nothing installed on the server or anything like that. And they're probably most analogous to MAPI advised syncs. If you use those, if you're writing a MAPI client, this is what Outlook would use. And so that's advising for events from a particular folder. The same kind of underlying mechanisms are at play here on the down at the store level in Exchange. So there's 3 mechanisms for receiving notifications. So this is, I've subscribed to a given folder or set of folders, and I want to get events back to me. And this is, as an EWS client, how I'm going to choose how I want those events brought back to me. So the first 2 are supported in Exchange 2007 and up. The last one here is Exchange 2010 and up, and Exchange Online. So starting first with push notifications. So this is, we'll look at the subscribe request for these and what you set up. But this is Exchange pushing events back to you. So you subscribe for events, and you just sit back and wait, and Exchange will contact you back. Pull notifications are a situation where you as a client are going out and you're asking for the latest events. So you're gonna be in a situation where you poll on an interval, and you may have numerous requests in your polling interval where you have no changes. So if you think of push notification, there's no traffic between you and the server unless actually something has happened. There is kind of a heartbeat interval that's about 30 minutes, but that's the only traffic you would have going between you and the server if there was nothing happening. Polling is going to be whatever your interval is, you're going to go back to the server and ask. So this can be a lot more chatty, for no work to be done, just to hear that there are no changes. So the balance kind of between that is streaming notifications, and this is very similar to like what an active sync client would do. So it's kind of like a hanging GET request. So you make a request to get events, and that HTTP request has a very long timeout, like 20-minute timeout. And then that request period hangs open, and if there are any changes that happen in that window of time, Exchange will, respond back, and you'll get a response back for those events. If nothing happens, you'll time out, and then you'll re-up your request. So this is kind of a nice balance between pull and push notifications. The thing about push notifications with something like Exchange Online, if you think about Exchange has got to talk back to you, so you have to be able to give Exchange an address to talk back to your server. And if your application server, your client's behind a firewall, it's not easy to, to give Exchange a URL it can come back to you on. So since streaming notifications are just that open, it's like a GET with a long timeout. It's just HTTP friendly. It's firewall friendly. It'll work pretty well with Exchange Online in different firewall and load balancing scenarios. Again, though, it's only available in Exchange 2010 SP1 and greater, and it's the preferred method for using notifications with Exchange Online. So here's some of the protocol links on this. So there's two kind of separate protocol documentations. This first one, it talks solely about push notifications. So there's a protocol around the requests. So basically, if you think about push notifications, Exchange is talking back to you. So you're playing the role of a client and a server in that situation. There's a WSDL that you're required to implement that Exchange is assuming that you'll be able to understand. So it's sending requests back to you in a particular format that you're going to have to know how to understand and parse. So that's all covered in this first document. The second document is notification. It's called notifications. It covers pull and streaming notifications. Then we also have here we have the MSDN links. There's an example application for push notifications, and then there's sample code for streaming and pull subscriptions. And this is all in the SDK. So looking at kind of the anatomy of these requests here. So this is a pull subscription request. So this is creating a subscription on the server. So this is the first request a client makes is, I want to subscribe to events on this folder, and it's specifically a pull subscription request. So you can pass it a number of folder IDs. So it could be any number of folders within a mailbox. And actually, so here we're using a distinguished folder ID. There's other, just a folder ID in and of itself is just a base 64 string. Encoded within that is the mailbox. So if you had folder IDs from multiple different mailboxes, you could subscribe to multiple folders across mailboxes in a single request and get events back for them. Then we basically have the event types, and I have another slide that will go through all the types you can register for, but this is an explicit list of events that you're saying you care about. Could be every event you could get, or it could just be a subset. Could be just let me know if there's new mail or deleted mail, or it's really deleted items, not particularly mail. So you set that here. There's also the timeout. So this is the timeout and duration of minutes. So this subscription can remain idle without a get events. So this is, again, a pull subscription. So what we're saying in this timeout value is that you're telling Exchange, hey, if I don't get back to you in 10 minutes, then something must have happened to me, and you can drop my subscription, and I'll just resubscribe next time. So that's what Exchange doesn't want to do, because these subscriptions are stored in memory on the CAS, is maintain an infinite list of subscriptions. It's going to go through and aggressively try to clean that up. So that's an important thing to consider. There's another value here which I don't have in the example, but there's the ability to subscribe to all folders in a mailbox. And so this is actually an attribute that you put on the pull subscription request, so it'll go up here. You just set that to true, and it indicates that indicates whether to subscribe to all folders in a mailbox. So you don't have to go through, iterate every folder in a mailbox and list all the folder IDs here. You can just say subscribe to all folders equals true. And then no matter if new folders are created or deleted or whatever, you'll get events for everything happening in that mailbox. So then the response you get back, so this is the response that comes back from that message. So you get a couple important things here. So you get a subscription ID. So that's a unique identifier for your subscription on that CAS server. So you remember that each time you go back and you send your get events request, we'll see that. You send that. This is the initial watermark that you get. So this is the watermark indicating where you left off. So when we subscribe, we get an initial watermark back. When we make a get events request, we're always going to send the subscription ID and watermark, and then we'll get our events back. So those examples were for pull. rather than walking through push and streaming subscriptions exactly, here's the notes where they are in the protocol. We also have, I just wanted to point out some key differences here. So with a push notification request, you would send this status frequency and URL because of the nature of what a push notification model is versus pull. So status frequency is how often you want Exchange to send back to you a heartbeat request to make sure that you're still listening. Exchange will send back a request as just a simple status event to you on whatever interval you supply here. And if you don't reply to that in kind, it will remove the subscription and move on. The URL is the URL that it should contact you back on. So this is what's problematic if you're just an app server behind a firewall in an enterprise environment, or you're just a client on somebody's PC that could be anywhere. It's hard to know what to tell Exchange to get back to you on as far as the URL. For streaming subscription requests, so you don't pass any kind of timeout or status frequency. You just have a timeout set on your web requests. So you send that request up. You set the folder IDs and the events that you care about, but there's nothing else. That's it. And then you just follow that up with a get streaming events call, which we'll look at, and get your events. So again, this is for pull notifications. So I'm setting the subscription ID and watermark. And I'm just saying, give me the events on this subscription ID, and this is the watermark where I left off. And it will basically go to the event queue for that subscription, and then give you every event since that watermark. This is what the response looks like. So you'll be returned that subscription ID. It'll return to you the watermark you sent up, and it gives you a new watermark. It will tell you here, and it'll tell you whether you're getting all of the events. So if there's a large number of events in the result set, it will break that up. And I believe in here in the get events call, you would set actually you can set the page size, so the max number of events you would want returned to you. So if the events in the queue overrun that page size, that value, more events would be set to true, and then you would know just to call get events again with the updated watermark, and you would continue through and hydrate the event queue on the CAS server for that subscription. You also get a timestamp, and you get the parent folder ID and change key. So if you're monitoring multiple different folders within a mailbox, or say subscribe to all folders, you get the parent folder ID for all of the individual changes, so you could go back and know what folder has changes in it. So there might be situations where you get a number of different event notifications in, say, like the calendar folder, when we have a scenario where somebody sends a meeting request, and they, if we just think about that, we send a meeting request to a bunch of recipients. That creates an appointment in your calendar when you send that meeting request. Then you start getting responses back. That updates the attendee status for each of those appointments. Then you may, update the status or update the time or propose a new time. You have all this activity that goes on. So in a given polling interval, especially, you may have a number of different changes on one single item or within one folder. So it's important to consider, as you're looking through this, take the results that you get back, look at it in total. Don't just start picking off change events one at a time without looking at the whole list of changes, because you might have multiple events relating to the same item or same folder. Here's some of the event notifications that you subscribe for. So separately, you can subscribe for copied, created, deleted, modified, moved. Those are all pretty self-explanatory. New mail event. So the difference between new and created, new mail is when mail is delivered to your inbox. If I go and I create an item in your inbox, that's just a created event. Just because it's the inbox doesn't mean it's a new mail event. It's actually when it goes through and it's delivered to your inbox or drops into your mailbox, actually, through transport, that you get the new mail event. Status event is that event, just that heartbeat event that comes from Exchange, just saying, are you still listening? And the FreeBusy changed event is an event that you would get only from an appointment item, and that would be if it's a distinguish between just a regular modified event, and if the FreeBusy status was changed for that particular item, if you changed it from tentative to busy or out of office, you would get this event plus the modified event. So you would know that there's a free busy status change. That's something that you would see like Link would use if it's trying to maintain and kind of update your status in the Link client. It may not really care about a modified event on a given appointment. It really just wants to know, did the free busy status change? And if it did, great. If I only got a modified back, I'll just ignore that event. So this was added in Exchange 2010, I believe, maybe 2010 SP1. So push and streaming notifications are more efficient than just polling, just going back to to a folder over and over again and say anything new, anything new, anything new. These are much more efficient. There's much less throwaway work. Polling with pull notifications is more efficient than using sync folder items. So we'll talk about sync folder items in just a moment. If you're familiar with MAPI, there was the idea of ICS, so that's a more resilient change synchronization mechanism, which you, in theory, could poll with. That's fine. But using a pull notification, because the event queues are stored at the CAS server level, the CAS server is kind of looking out for you. It's maintaining your subscription and caching the events. And so when you use pull notifications to poll, you're actually pulling from that queue. You're not making a back-end mailbox RPC versus sync folder items, which is actually going all the way back to the mailbox server, synchronizing changes and coming back to you. So if you're going to do polling, it still makes sense to use pull notifications rather than sync folder items in most cases. And another advantage to pull notifications is they can go, like I was describing before, it can go across multiple folders in a mailbox or multiple folders across mailboxes where sync folder items can't. And then another interesting note, the watermarks that we were looking at in these requests, those are much smaller than the sync state that we will look at with the sync folder items call. So just in terms of the amount of data that you're sending and receiving over the wire, the watermark's going to be smaller than a sync state. Good. So we talked about this a little bit, and I can show you this in a demo. I'm actually going to push through, and then we'll do the demos at the end. But the subscriptions are stateful, stored on the CAS. So if the CAS goes down, or you're not managing affinity, and your requests are going through like a load balancer and ending up at a different CAS server every time, if that request for get events or get streaming events doesn't end up at the same CAS server that knows about your subscription, it's going to reply back and say, I don't know what you're talking about. And you're going to get an error back. So managing affinity and then being cognizant of the fact that if a CAS server goes down, you may get an error and have to resubscribe is important. So in that scenario where you get an error back and you say, hey, I don't have that subscription. It's like an error, subscription not found. It's very important to understand how you can recover from that, and we'll talk about that, I think, on the next slide here. Yeah. So what happens is when that CAS server goes down and you're essentially losing your watermarks. There is the ability for Exchange to kind of recover from that, but it's very expensive, and so it's not really worth putting Exchange through that to do that. So there's just some kind of really more intimate details about what is going on there, how it recovers through a linear scan of interesting events. It can recover, but it's really easier just to drop your watermark, drop your subscription, and resubscribe, and you'll get the events. And you'll start getting events again, versus paying the penalty for this linear scan and recreation of the watermark in the subscription that you previously had. It's better just to move on. So if that does happen, again, create a new subscription, throw away your old watermark, and there's some folder properties to look for that can clue you into changes that may have happened. So if you think about it, if you're doing like pull notifications every 15 minutes, you're polling every 15 minutes, then all of a sudden a 15-minute interval goes by, you send your get events request, and you get error subscription not found back from Exchange. Well, you don't know when in that 15-minute interval that just elapsed the exchange went away and stopped monitoring events. So you really have no idea. Nothing could have changed. A whole bunch of things could have changed. So one thing you could do is you can use these two extended properties on the folder itself to look at one, the local commit time max. So these are actually documented in the protocol too. This is actually in just kind of the MAPI props document. I should have had the name of that protocol document in here. But you can look these up. So you'll see if you're keeping track of this property, each time you get changes back, you can compare the current value to the last one you noticed. And if it's incremented, then there were updates that happened in that folder. Same thing with the deleted count total. You would notice that increment as well. So those are two properties you could check to say, hey, did anything happen while I wasn't getting events? As we'll talk about in a moment, sync folder items is probably a better way to handle that scenario anyway. Talked about this a little bit already. So notifications can be noisy. There's certain things that happen in the Outlook client that aren't that involve multiple updates, creates, and deletes to different items and different folders. The meeting request scenarios are a great example. So it's not an aggregation of what the delta between where you were and where you are now. It's that event queue is filled up with every incremental change that happens. So an item was created, then modified, then updated again, then deleted. All of those things are individual events. And you'll get all of those things as individual events, so it's important not to process them all right away. And even in some calendar situations, if you're using like get streaming events or push notifications, you'll start to see some events come in for calendar scenarios where the meeting's being created, it's being updated, it's being sent. And so if you delay your response to those events, if you're trying to go out and retrieve those changes as they come in, if you just put a couple second delay in there, that gives the actions that Outlook is taking enough time to finish, and then you can kind of settle and aggregate what you're looking at, so you can see that I had a bunch of changes to this item, but it was ultimately deleted, so I don't care about it. A number of changes happened in this folder, so I'm just going to synchronize it, etc. But you can get into scenarios if you're monitoring the calendar folder where you're just getting a lot of notifications and you're sending a lot of get item requests to try to keep up, and it can be hard to do that. So any questions about notifications? So related to that is synchronization. So synchronization is, again, it's a lot like MAPI in what you had with ICS. And you'll see Outlook use ICS. You'll see an Exchange Web Services client use sync folder items to synchronize the contents of a given folder. Here's the protocol documentation where we talk about that. There's sync folder hierarchy, which is the same thing for the hierarchy of folders within a mailbox. Used less frequently, potentially, but it's the same benefit. So you're syncing. You're finding out if there are any changes to any folders within a given under a given root folder. Sync folder items is going to give you all the change information of items within a given folder. And we also have SDK documentation on that. There's a sync folder items operation. Obviously, the sync folder hierarchy operation is documented too. And then we have an example of using sync folder items to sync contents in a given mailbox. So this is what sync folder items looks like. So unlike notifications, there's no subscribe or anything like that. The sync state and all of that is stored at the mailbox level. There's nothing unique to your relationship of your client to the mailbox server, CAS server, or anything like that. You simply say, you specify an item shape, and we talked about that. So here's another example. I'm showing you default. Here's the base shape. I'm about to tell you not to do that. But you can do it. Sync folder ID. So this is the folder ID, not folder IDs, but one ID. One folder. It can be a distinguished folder ID or a specific folder ID. So that's the folder you want to get items from. Then you have a sync state. So this is the state that indicates where you left off when you last synchronized. Unlike notifications, this is stored at the mailbox level. It's resilient. So just like the mailbox is resilient, this sync state is resilient. You can specify item IDs to ignore. So you can say, if you determine that you don't care to hear any more events about a particular item, you can specify that item ID here, and you'll never get a notification on that. You can't say ignore items with the subject XYZ or anything like that. It's only specific item IDs that you can ignore. And then you specify the max changes returned. So that's essentially your page size and your result set. So then the sync folder items response. So you get back a new sync state. And you get back a very similar element, includes last item in range. So that, if that's false, if you're using paging and the events that you're getting back are outside of your page size and you have more changes to get. And then you have a changes collection here, which would include all the creates, updates, deletes, et cetera, different changes that happen in that given folder. So these are the different change types you'll get back. Create, update, and delete, pretty self-explanatory. Read flag change or red flag change here. So this is interesting because remember we were talking about the is red flag. So we distinguish between an update, just a general update to an item, and just the is red flag being updated. For a given item, if you just saw this flag or this event come back, then you know that flag was the only thing that was flipped. You can just update that on your client. You don't have to do a get item call to find out what properties are changed. You just simply can look at that, you know exactly what happened, and you move on. These are documented here. Here's the protocol notification or the protocol section of the sync documentation here, where these are documented. So again, unlike notifications, the sync state is reliable across CAS servers. They're stored at the mailbox level, so they'll survive a CAS server going down. They'll survive a mailbox failover, that kind of thing. Unlike notifications, a sync folder items always results in at least one RPC, so one remote call from the CAS server to the mailbox server. Not a huge penalty, but a difference at a particular scale that would make a difference in considering whether you're going to use notifications or you're just going to pull with the sync folder items. So just like a find item, we only want to ask for the properties that we need, and really the only thing we need from sync folder items is tell me the IDs of the items that were created, updated, or deleted. You don't need to know anything else, or you could, in theory, it kind of makes sense that you would want to go ahead and just request all the properties you care about, such as subject or recipients or something like that, but you really don't want to do that because for a given sync folder items request, we do a lot of optimization. So if I do a sync folder items request and one request for ID only, and there's maybe 100 items that have been changed, updated, and deleted, it only costs me one RPC to get that result set back to me of just all of these item IDs. If I add to my property set, if I add to that, say the subject, I'm adding an additional RPC for each individual item. So what's happening is the Exchange server is keeping track of all of the changes, and it can very easily say, I've had all of these changes, here are the item IDs, but then if you go back and you ask, in addition to ID only, you ask for subject or you ask for all properties, it then has to go back and do an RPC individually for each item it's going to return to you and get those properties that you're requesting. So you're greatly increasing the latency of your sync folder items request. You may have to go back and do a get item request, but that's okay, considering that in some cases, when we're looking at the events that we get back, we have events like read flag change or delete that we may not do a subsequent get item. So we don't want to pay the penalty of doing that RPC unless we really need the information. It might also be a situation where we've done an update, and we know we've done the update. We sent the update item request. We did sync folder items. We get an update event back, and we can match up the change key and say, hey, yeah, that's the change I just did. I don't need to follow up that item. I have the latest state. So this is an important note here, and we can look at that if we have some time in the EWS protocol logging that we're looking at before to show you the difference here. So just a note here, this is really in a client scenario. So a lot of clients, they want to sync newest items first, And so we took that feedback and we implemented that change in Exchange 2010 SP2, and you'll see that in Exchange Online and Office 365. But prior to that, we did oldest first. So this slide actually used to have a lot more information about if you really wanted to sync newest to oldest, and we were giving you information back on oldest to newest, how you could do that. But primarily, you're going to see this kind of fix itself in that Exchange 2010 SP2 returns you the results from a sync folder items newest to oldest. So in a client scenario, that's important when you have a folder of a lot of items. You're doing like a paged view of 25 items at a time or something. And then the client can actually, populate the most relevant information at the top. A client like Outlook 2011 or something like that. That was a big request for them. So I talked a little bit about ignoring specific item IDs. If you want to go beyond that and do some kind of filtered synchronization, you really can't do that through the schema. There's no real way to do that with a sync folder item. So if you only want to sync a subset of data, basically what you want to do is call sync folder items with ID only until no more changes come down. So essentially what you're going to do is get a sync state value that's up to date. So it's the latest sync state of the state of that folder. And then, so you've got your latest sync state, and then you're going to do a find item with sorting and paging to kind of pre-populate the set of results that you care about, display that. Then you have your latest sync state, and you can use that going forward to look for changes. And if there's changes within the item set that you care about, you can update those items. If there's new items created, you can go see if those are items that you care about. Any questions about synchronization in general? So this last section is about putting notifications and synchronization together. So this would be kind of how a client like Outlook will kind of put both of these two things together and synchronize and keep synchronized mailbox data. So basically, there's 3 steps and three ways you use these things. And basically, use notifications just to determine what data has changed, or when data has changed. So notifications have a lot of detail in them. They give you created, updated, deleted events. They give you new mail events. Some of that may be useful, but primarily what you want to think about is just use notifications to tell you that changes happened in a given parent folder ID. And then take that parent folder ID and call sync folder items to determine what changed in that folder. This is typically because notifications don't tell you about the is read flag changing. They don't make a distinction there. So if you only use that, you do a lot more work. That's one of the most, it's a special case property because it's one of the most frequent properties to change. It's highly optimized. So using this pattern will allow you to do that. You'll also get the benefit of notifications in like a streaming or a push scenario, so you're not being real chatty. You have the minimal amount going over the wire waiting for a change to happen. But at the same time, you're using sync folder items to determine what changed because the sync state is much more resilient than the watermark. So you get the benefit of notifications and not having chatty communication, not having to poll, but then you get the resiliency of the sync state versus the watermark. Then you use a get item to retrieve the data you care about. You can pull down, you can do optimizations based on the number of sync events that you get back, and then you can optimize the batching that you do at the get folder or the get item level to organize those get requests into batches that make sense for the amount of data you pull back. Synchronizing calendar data. So this is kind of putting that same pattern together in a situation where you're looking at using a calendar view. So you notice with sync folder items, there's no calendar view or anything like that. There's no calendaring logic. So basically, the bottom line here is use the built-in calendaring logic. Use a find item with a calendar view in the calendar. Don't poll with the find item plus a calendar view. Instead, you can use notifications, and you really don't need to use sync folder items here. You could basically just do a notifications plus a find item with a calendar view. And you basically will get notified of any changes in the calendar. Then you use the find item to go back within the start date and end date range that you care about and pull all the changes that happen within that range. And then use a get item to follow up if you need to do that. Again, this will give you, this actual pattern of using all 4 of these together would give you the benefit of the notifications, the resiliency of the sync folder items, the calendaring logic of the find item, and then you use the get item to get any additional data that you couldn't get through that find item, like the body of the appointment and recipient information, attachments, that kind of thing. So synchronizing search folders. So we talked about that a little bit at the beginning. You can still use notifications to determine when a change happens in a given search folder. So if your search folder is just looking for any mail in your mailbox with EWS in the subject, you can subscribe to that search folder and get notifications for any time any of one of those items is created, updated, deleted, etc. What you can't do is use sync folder items against the search folder. So then you use a find item. You can sort that based on like last modified time, and you'll find the latest, basically the latest changes based on the fact that you're sorting by last modified time, maybe storing the modified time of the last time you checked and looking for anything newer. Then you follow that up, just like the normal pattern, you'd follow that up with the get item to retrieve the data. So some optimizations here. We've kind of already talked about these with notifications. If your notification was alive before your last sync folder item's called, then you don't need to do any kind of follow-up in a deleted events. Notification adds and changes should be followed up with sync folder items. This is a scenario where you're getting the change key back. So if you had an update on an item and you did the update, you're storing the change key so you can compare the change key back to the event notification, to the sync folder item notification to see if you got a change key. We talked about the is red flag change. Talked about that. So don't use sync folder items on search folders. We talked about that as well. Use a page find item. Any questions on that? Again, this is all stuff that you would see over the wire, even for a Outlook 2011 client. That the native Apple Mail client talking to Exchange will use EWS. You'll see that on the wire. You'll see these things, maybe not used exactly to the best practice. These best practices are mainly written for the supreme, scenario of a high-scale service application. If you're trying to get ultimate throughput, this is what you would do. Not necessarily what every client, doing a client to server scenario would do. Any questions on any of that? All right. I can show you one thing here. So we will look at, in here, EWS Editor has this idea built into it, the pull notifications and streaming notifications. And I know this is probably small for you guys to see. But just to point out, you do have the ability to go to a given folder very quickly, subscribe to a folder, and then call get events, and you can kind of go through that and see how that works, see how you get changes back from a given folder. Do changes in Outlook, certain scenarios, then call get events, see what event notifications come back, and kind of try to understand that. Let me pull this up. So I'm going to go over to my Exchange server. So this is this is on my Exchange server. I'm going to the logging folder. So this is where I was saying it's this log information in Exchange 2010 SP2 is not in the IS logs. It's actually in this logging folder under the Exchange directory on the Exchange server. And if I pull this up, you can see the content here. And so what I want to look at is, I'll pull this down. Save this. So what I'm doing here is just kind of very cheaply bringing this data back into my Excel spreadsheet here. So this is, what I'm going to do is refresh this pivot just to look at, hopefully look at, yeah. So we can look at sync folder items. Let me go back here and look at this first. So I did a couple, we'll look at sync folder items first. So this first sync folder items call, we'll compare. So this is line 13 and 14. And we'll scroll to the end here. And I did one with ID only and one with, again, there's 50 items in the inbox. And I intended to do ID only. So this is the difference between, for the same set of changes for sync folder items, the number of RPCs. You can see the individual latency. This is an average. Both of these are averages. No, there's a total. Anyway, the difference in our total number of RPCs is different. The actual difference here, if you notice that, the total request time. So this is an optimization here in that I hadn't called sync folder items initially. So this is building the initial change list. If I went back and made this call again, this would be much more efficient, solely based on the number of RPCs that are going back. So the significant number up here in my bad demonstration here, not proving myself right, but my RPC count here, at least at this level, you can see 58 versus 3. And then if we look over at the pivot, again, what we're looking at here is we're looking at the total RPCs to do a subscribe and an unsubscribe. So these are handled, this is all happening at the CAS, client access server level. So there's no RPCs. There is work being done, obviously. So there's a request time. And you can see when I call get events and I get events back, there's no RPCs. There is time taken, though, because this is the total time that the CAS has to go through its queue, collect all the events, create a response, and send it back. So it's all a balance. You look at the scenarios that you have in your application. If you're writing a service, if you're writing a client, you do work like this to optimize specific scenarios that you care about. And so, using Excel like this, using the protocol logging like this, really helps you do that. And I'll show you, see if I can prove out my subscription scenario where I'll show you how they're maintained on the CAS. So if I go to this specific folder, I'll subscribe to it, I'll call get events, and I'll go back here, let's say, and I'll delete an item. So I deleted an item, and I get events on that. So I get a folder event that something in the folder was modified. It's very tiny, that's what it says. And then the other event here is just an item event deleted. So I'm getting notified of events happening in this folder is the point. If I go over to my server, and I log in here. Having Hyper-V on Windows 8 is great. So this is small business server running on my dev box. So basically, I'm just going to IIS reset just to basically wipe out, the CAS worker process and restart it. So essentially, if something happened on the CAS, it went down, it had to restart for whatever reason. If I go back over here and I were to call get events again, I'm going to wait for it to come back up just so it's running. The CAS server is recovered, but then I'm going to call get events and my subscription is going to be gone from memory. So hopefully it restarts soon. There we go. So now I call get events, and it's going to search for my subscription ID, and ultimately it's going to fail or hang. Point being, it doesn't work, but we'll see when it comes back. This might be trying to break into the debugger. There you go. So it failed here, and you get this error. You can't see this obviously, but it's error subscription not found. So that's just an illustration of how that's resilient. I could walk through the same thing with the sync folder items, but you can take my word for it that it would not fail after coming back from that restart. All right. Any other questions? Any questions at all? All right. Thank you very much.
Question.
Yeah, sure.
Like it's more like implementation
Sure.
related, not protocol related. But when you say you have RPC calls between the CAS and the back,
Yep.
that's it. But at some point you say there are some operations that don't have RPC calls. Does it mean that you have different ways to communicate, or the CAS has a storage inside of the CAS?
Right. That's it. So that's a great question. So the question is, we talk a lot about RPCs, and we send an EWS request to a CAS server. How does that not relate in an RPC somewhere, right? So the idea is that the client access server in a situation like for notifications is maintaining a cache. So there may be RPCs going back and forth between the CAS server and the mailbox on an ongoing basis in the background, but it's not related to the request that you send. So in that log where I'm showing no RPCs, okay. So when I'm showing no RPCs here, that's not saying that the CAS server never talked to the mailbox server. It's just it doesn't have to do it for the purpose of fulfilling that request.
So it already did it offline.
It maybe already did it offline. It does whatever optimizations it does to reduce the number of RPCs that it has to make to facilitate your request at that time. Yep. So there is, in a large part, it's not about getting down to zero. It's just about minimizing the RPCs because the CAS doesn't maintain a lot of that state information. It's mainly about minimizing the total number of RPCs or the latency between the CAS server and the mailbox server because you know that any given EWS operation is going to result in some RPCs. This is a rare case where you have some that just result in no RPCs. Good question. Any other questions? All right. Thank you.